Good day, grade 12 learners. Welcome to today's session on mathematics learners, a subject. My name is Mpho. This lesson is proudly brought to you by the Gauteng Department of Education. And because we want this lesson to be interactive, our WhatsApp interactive number is 064 748 8913. I'll repeat the number again. 064 748 8913. If you have any question, just WhatsApp your questions to that number. So today we are looking at topics in paper 2 in mathematics. This is just in time revision program. So the topics that we'll be looking at is Euclidean geometry, and if time allows, we'll go to trigonometry. Remember, these two topics takes 60% of the paper. Now, before we move forward, let us just look at the weighting of the topics. We have 4 topics in paper 2, and already in the prelim, these topics were there. The first one is statistics, which is 20 marks, plus minus 3. Analytical geometry, 40 marks, plus minus 3. Trigonometry, 50 marks, plus minus 3. Euclidean geometry is 40 marks, plus minus 3. So we can see that the two topics counts 90 marks, which is 60% of the paper. Now you need to divide your time when you start your paper, because you start writing at 9 o'clock. So statistics, which is 20 marks, use at least about 24 minutes to answer the questions on statistics. Analytical geometry, which is 40 marks, use about 48 minutes to answer analytical geometry questions. Trigonometry, again, another 48 minutes to answer the question. Trigonometry is 50, use about 60 minutes to answer that question, about an hour. Euclidean geometry, which is 40 marks, use about 48 minutes because you have 3 hours to answer this question. A mark, it's about 1.2 minutes. Now, these are the cognitive levels. Remember, for a paper to be on standard, to be of the required standard, to be a standardized paper, there are cognitive levels that needs to be followed. So we're using TIMSS here. So we have 4 levels. Level 1, which is knowledge. It takes 20% of the paper, which is about 30 marks. Level 2, it's routine procedure, which is 35% of the paper. So level 1 and level 2 takes about 55% of the paper. So these are questions that are accessible to you, because these are questions that you should be able to answer. And then the next level, it's level 3, which is complex procedure, which is about 30% of the paper, which takes around 45 marks. Then lastly, we have problem solving, which are non-routine procedure questions. So it's about 15%. So level 3 and level 4 takes 45% of the paper. So therefore, then the paper will be a standardized paper. Now, this is an information sheet. When you wrote your prelim, the information sheet was there. And it's at the end of your paper. And you are familiar with this because you've been using this information sheet since the beginning of the year. There are some formulas that are here on the information sheet, and there are some that you need to know them. So the ones that are on the formula sheet, please use them effectively and efficiently. Copy and paste. Don't make a mistake of writing an incorrect formula, whereas the formula is on the information sheet. And you can see that on this information sheet here, on that part, we have our paper 2 formulas that are there on the information sheet. So please make sure that you copy and paste these formulas when you are answering questions so that you don't make a mistake of writing an incorrect formula. Now, there are common errors, common mistakes that were found in the diagnostic report to say these are the common errors that learners are making when answering questions. So the first common errors that we're going to look at are common errors on Euclidean geometry. Making assumptions without proving. Please, please, please never make assumptions. For an example, if we have a circle and there's a line that is drawn there, let's say that is line PQ, and we have a triangle, and that is R. Don't make an assumption that PQ is a diameter unless you are told or you have proven it. So don't make an assumption by looking at the diagram and saying PQ is a diameter. That will be an assumption. So assumptions are not allowed. Please don't assume. The next common error is incorrect reasons. Your examination guideline has got acceptable reasons that need to be used. Make sure that you write the correct reasons. So the diagnostic report shows that learners are making mistake by writing incorrect reasons, and that will make you to lose a lot of marks. Incorrect construction when proving examinable theorems or when there is no construction at all. Remember, examinable theorems are part of theory, and paper 2 has got theory. There's a maximum of about 12 marks on theory. So when we are talking to examinable theorems, we are talking about those theorems that you must prove. And you are going to get one of them in an exam. And these examinable theorems, when you prove them, you must do a construction. So common errors is that most learners don't construct, or the construction is incorrect. The next one, writing statements without reasons. In Euclidean geometry, it's very important and critical that every statement that you put, it must be accompanied by a reason. And it must be a correct reason, not just any reason. So the reason must be correct to that statement that you have given. So the statement that you give when you do Euclidean geometry must have a reason. So we've seen that most of the common errors or the mistakes that learners do is that they don't give reasons. Next, proving an incorrect reason when proving something like a quadrilateral. To say you provide an incorrect reason. They say prove that a quadrilateral is cyclic. At the end, you say therefore it's a cyclic quad, and the reason that you give, you say opposite angles of a cyclic quad. You don't have to mention cyclic quad. You would rather say converse, or you write the converse. So once you say opposite angles of a cyclic quad, you are providing an incorrect reason. That reason is not correct because you are proving that a quadrilateral is cyclic, but your reason says opposite angles of a cyclic quad. So it means you are concluding that already it's a cyclic quad, instead of saying opposite angles of a quadrilateral, because you're proving that it's a cyclic quad. So these are the common errors that are mentioned in the diagnostic report year in, year out. Please, now for this last push, make sure that you know your reasons. Make sure that you provide the correct reasons. Make sure that when you prove your examinable theorems, you do the correct construction and you construct, because if you don't construct, then you will lose marks. Then you are unable to mention the correct proportions. Now, when we talk to proportionality and similarity, the proportions must be correct. If the proportions are incorrect, you lose a mark. So make sure that the proportions that you write are correct. Make sure that when you are proving similarity, the triangles that you write are in order. So because most of the time the errors that are made is that the proportions that are written are incorrect. And labeling angles incorrectly. Make sure that you label your angles correctly. If you want to talk to B1 plus B2, write it as B1 plus B2. Or you can use 3 alphabet. You can say angle A, B, C. So label the correctly, because most of the challenges or the errors that you make is that you label the angles incorrectly. Now, let's go to the examinable theorems. The ones that I've just spoken about, to say when you do the examinable theorems, learners make common errors that they don't construct or they do the incorrect construction. We have 7 examinable theorems. 5 from grade 11, 2 from grade 12. So these forms part of theory in paper 2. Remember, I mentioned that in paper 2 we have a maximum of 12 marks of theory. So your examinable theorems forms part of your theory. Now you need to know these theorems. You can get one of these theorems in your exam paper as part of your theory. So the first 5, grade 11, and the last 2, grade 12. Now, remember when you prove these theorems, you need to perform a construction on the examinable theorem. And we are advising to say, please use broken lines so that you can differentiate and be able to see your construction. And once you've done your construction through using your broken lines, it's not necessary again to go and write it again, because we will see that construction by the broken lines. So it's very important that you construct when you prove your examinable theorems. So those were the theorems in words. Now the theorems are now drawn. So these are diagrams that goes with the theorems. So you can see the first 2. These first 2 are theorems from grade 11. And I did say construct. So now the construction for grade 11, it's only one construction for all the 5 theorems. You construct the ready. Construct the ready. So the construction for all the 5 theorems for grade 11, it's constructing the ready. Remember, I said the construction should be correct for you to be awarded the mark. So when you are proving examinable theorems, you need to be very accurate. Now the construction here, one construction for the 5 theorems, the ready. The first one, the line drawn from the center of the circle perpendicular to the chord bisect the chord. The diagram will be given to you and the information will be given. Now you need to do a construction and a correct construction for that matter. So the construction, as I said, for the 5 theorems of grade 11, same, ready. So you will join from O, which is your center, to A, which your center, so that will be your construction to the circumference to point B. So that will be your construction. That is the examinable theorem, the first one. Please learn that theorem. The second one, line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. Remember, when you're proving a theorem, an examinable theorem, construction is said, it's one construction ready, the ready, and the radius. So this is the second theorem that you must learn, part of theory. Again, these theorems will be used in solving geometrical riders. Now, the next theorem. The angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at the circumference of the circle. This theorem again is examinable, and it has got 3 diagrams. So any one of the diagram can be examined, can be assessed. Again, it's an examinable theorem. Remember construction, correct construction, and as I've mentioned, one construction for the grade 11 ready. So you will have again your radius, which will pass at the center. You extend that line. So that pass at that center, which is radius, so that point from B until the center is a radius. Again, that diagram you construct, that will be a radius, you extend that line. Then you can be able to write your 2 and your 3 because you're going to use that, labeling your angles so that it makes it easy for you to be able to prove your theorem. Again, construction, remember I said it's one construction radius, you extend your radius, then you can be able to prove your theorem. So that is your second theorem, your grade 11 theorem. Now the next one, opposite angles of a cyclic quad are supplementary. So this is the second group of theorems under cyclic quadrilateral. So this is the next theorem that is examinable. And this is the fourth one. Remember again, you need to construct, because when you're proving theorem, construction is very important. Again, one construction, join the ready. You are proving that angle B plus angle D equals 280 degrees. So we'll join C and A. Again, ready, as I've mentioned, it's one construction ready. You write 1, you write 2, then you'll be able to prove your theorem. The last one. The angle between the chord and a tangent to a circle at a point of contact is equal to the angle in the alternate segment. Again, this is an examinable theorem. The proof, remember again, construction very important, and you need to be accurate and correct. Again, remember I talked of the radius, one construction, you join your ready, you extend it, then it becomes a diameter. Remember a diameter has got 2 A ready, then you join to D. Then you can label it 1, 2, then you can have your P. So these are your grade 11 theorems. One construction, join the ready. Your grade 12 ones. So this is a grade 12. Line drawn parallel to one side of a triangle, divides the other 2 sides in the same proportion. Again, it's an examinable theorem. You need to construct. And you construct your triangles and you construct their height. Constructing your triangles, you join your B to Q and you join P to C. And again, from P, you construct a height. That will be our height. We can label it small letter h. It's a height. Again, from Q, we construct a height. We can label it R, it's your height, it's your 90 degrees. So construction is very important for you to be able to be awarded all the marks. So this is your proportionality theorem. And the next theorem, it's your similarity. If 2 triangles are equiangular to one another, the lengths of the corresponding sides are in proportion. Again, you need to construct, as I've mentioned, that the construction needs to be correct. Now, here we are construction on triangle DEF. We joining a line here. We call that line PQ. Remember to show that DP is equals to AB for your construction to be correct. AC equals to DQ for your construction to be correct, because the first part of this proof, you are proving that ABC is congruent to DPQ. So these are your examinable theorems. But remember again, these examinable theorems, we use them when we do our riders. Now this is just a reminder on proportionality to say we have different ways of writing our proportions. We can write our proportion in fractional form. We can write our proportion in product form. That is your product form. That is your fractional form. We can write our proportion in colon form. And in colon form, you can be able to take it back to fractional form. Even in product form, you can be able to take it back to fractional form. But remember, when it is in product form, you need to divide for you to take it back. But when it is in colon form, when it is A is to B, is the same as A over B is equals to C over D. So these are the different proportions that we can have. And again, in bullet number 3, if we have A over B is equals to B over C, A is our first proportional, and C will be our third proportional. And B, because we multiply B and B, it becomes B squared is equals to AC. We call it the mean proportion. And the last one is just to show you the proportions that can be written in different ways. This is still in fractional form. We have A over B is equals to C over D. Now when we exchange, we have B over D, that is the B over D. B over A is equals to D over C. You can see our B here, it's now our numerator. Our D is our numerator. Our A becomes our denominator. C the denominator again. So these are just different ways to write your proportions. So in any way that is given to you, you must be able to access it and know it, that the proportions can be written in different ways. Now in Euclidean geometry, when you do your Euclidean geometry, you need to know all your theorems. And you need to be able to apply them. Your theorems and the converses for grade 11, they are very important. And remember, we talked to Euclidean geometry, we talked to analytical geometry. The same properties that you have in Euclidean geometry, you are still going to use them in analytical geometry. The corollaries, there are corollaries that are there. You need to apply them. And Euclidean geometry needs you to be visual. You must be able to visualize your diagrams. You must be able to visualize your theorem. So it's very important for you to be able to see your visuals. And geometry that you have learned in earlier grades is very important. The geometry of lines, the geometry of triangles, quadrilaterals, very important because we use it here when we do our Euclidean geometry. And again, your midpoint theorem, which was done in grade 10, it's a special case here in proportionality. And your converse theorem for proportionality and similarity. And again, your Pythagoras application. So we are going to use it for application purposes. And these are just the things that you need to understand when you need to prove. If they say you must prove that lines are parallel, you either prove the alternating angles are equal or corresponding angles are equal or co-interior angles are supplementary. So these are just the ways to say when you have to prove that a quadrilateral is cyclic. What is it that is expected of you to do? You need to prove that opposite angles are supplementary. So these are the converse theorems that you must know for you to be able to prove. So these are just the things that you need to know. To say, if you have to prove that it's a tangent, so you need to prove the converse theorem with the tan chord or prove the line that is perpendicular. So if you have to prove that triangles, two sides of a triangle are equal, you prove that opposite angles are equal. So these just guide you to say if you have to prove. Now, in Euclidean geometry grade 11, we have 3 types of questions that will be asked. You have numerical, you have in terms of x, you have proof. Numerical will be easy questions that fall under level 1, level 2 questions. In terms of X, that will stepping up the questions. Prove, that will be normally high order questions. So these are the 3 types of questions that will be asked in Euclidean geometry grade 11. In proportionality, remember, when you work with proportionality, you work in one triangle at a time. That is very important, learners. Very important. Because the proportions that you write will be in one triangle at a time. Remember that. You're working in one triangle at a time. And you can be given lengths. You can be given ratios and lengths. Remember, there's a difference between a ratio and a length. A ratio is not a length. You can be given 2 ratios. You can be given 1 ratio if you want to step up the questions. So this is what can be given to you. And remember, we have areas that we need to know. So there are 2 cases that we're going to use. If you have common angles, it's advisable to use the area rule. If you have common height, use the area of triangles. Or line between parallel lines, triangles that are between parallel lines, and the common vertex. So when we're doing the areas, you see we are going to do some examples related to that. Now on similarity, we're working in 2 triangles at a time. And in similarity, we are going to talk to direct application and indirect application. So in similarity, we'll be looking at these 2 applications, direct application and indirect application. Now, when we're talking to direct application, it's when you are given 2 triangles and you must prove that the 2 triangles are similar. So that is direct application, because directly you are proving that triangles are similar. Indirect application, it's when you are given ratios in different form. So indirectly, you first have to prove that triangles are similar. Then from there, you will be proving one of those proportions. So that is indirect application. Now again, on similarity, these are interrelated 3 concepts. These 3 concepts are interrelated. Your equiangular, your similarity, your proportionality. So they are interrelated. So we are going to use all of them together. That is why we're saying it's very essential to utilize the 3 of them. Now, these are the tips that you must use when you are given a rider, to solve a rider. Read the given information more than once, or at least twice, so it assists you. So read it at least twice, more than once, so that it sits in your mind. Now, very importantly, with Euclidean geometry, we have a lot of diagrams that are there. Now, first of all, when you are working with Euclidean geometry, you need to analyze your diagram. Very important. Analysis of a diagram. And you will see when we come to an example that when you analyze a diagram, you will be able to answer your questions before you could even look at the question. And when you are analyzing a diagram, look at the keywords. There are keywords that are given there. And those keywords are very, very important. They are the ones that will guide you, that will lead you to look at the more information. And you must look at the information in the diagram, which is very helpful and useful. So the diagram that will be given to you, you'll have information that is useful and helpful. And again, the use of colors. Mark off using colors. Mark off your angles, your sides using different colors. Get crayons, highlighters that you can use so that you can be able to use those different colors on your diagram. And look for implied information. Implied information is which information? For example, if we give you a triangle and we say this is triangle ABC, and we say in triangle ABC, AB is equals to EAC. It implies, it's that information that we say therefore. So it's that implied information. Because we won't give you all the information. The other information, you must be able to deduce it from the diagram that is given to you. So if we say ABC, it's an isosceles triangle. Therefore, the angles that are opposite, those sides that are equal, will be equal. So that is the implied information. So the implied information is the therefore information. So it's very important, because when we work with Euclidean geometry, we are going to get a lot of information where we need to deduce and make that therefore. To say they give you this, you make that therefore. Again, brainstorm and develop a rough proof, especially when you come to questions where you need to prove. They say prove that. Brainstorm and have a rough proof. And Euclidean geometry needs you to link. There's a lot of linking that you're going to make. So you need to link the information. The information that you deduce on a diagram, you must be able to link. And from there, you can be able to write your formal proof. Now, these are just examples of keywords. Parallel lines, triangle information, center, diameter, cyclic quadrilateral, tangents, chord, etc. Cyclic quadrilaterals, those are the examples of your keywords. Now let's get to the maths. We've been talking. Now whatever that we've just talked, that skill, those steps, we need to apply them here. Now if you look at this question, there are no questions there. There's a diagram and there's that information. Now that information that we've just discussed in the prior presentation, we must use it here. So we are going to use that here. Remember, I said read your information at least twice. When you read it for the first time, just read the information without relating it to the diagram. So let's apply. I'm going to read it for the first time. O is the center of the circle. KOM bisect chord LM. And angle MNO equals to 26 degrees. K and P are points on the circle with angle NKP equals to 32 degrees. OP is drawn. I've just read that information and now it starts to make sense in my mind. And the visual diagram is there. Now I start looking at the keywords, analyzing the diagram. Remember we said you analyze. And when you are analyzing, you look at the keywords. Now it says O is the center of the circle. Our keyword, let's circle it. Center of the circle. Now I relate it to the diagram. Now in grade 11, we have our center theorem. And this word center has got terminology that goes with center. Once I see center, you think of what? Of your radius. You think of what? Of your diameter. You think of what? Of your center theorem. Line drawn from the center of the circle, perpendicular to the chord, bisect the chord. A line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. Can you see? Those are your center theorems. You need to think of all your center theorems and you visualize them. Now, let's just look at until there, the center. We analyze the diagram. Remember, marking off using color. Now, center as our keyword. Let's mark off. Center, it's O. The radius, OK, it's our radius, we mark it off. OP, it's our radius, we mark it off. Do we have another radius? Yes, ON, it's our radius, we mark it off. We can see that we've marked it off. Remember, this diagram is like a skeleton. You are putting flesh on it so that that flesh can be able to assist you to answer questions. So we've marked off. And once you've marked off that, if you look at triangle, remember we talked of triangle information, OKP, you can see that it's an isosceles triangle by merely analyzing. And once it's an isosceles triangle, if OK equals to OP, therefore it means K1 plus K2 will be equals to angle P. Mark of the same, angle P. Now again, center. Remember I talked to center theorems. Do we see a center theorem? Yes, there is. Wow. A line drawn from the center of the circle to the midpoint because they've marked off LM and MN. Remember, we're still on the center. Is perpendicular to the chord. The implied information, therefore, your deductions. OM is to the midpoint. Therefore, this angle will be 90. That angle will be 90. Triangle information. Triangle OMN is a right-angled triangle. Triangle information again. Remember, I'm still on the circle. And again, these angles were written for me on the diagram. Once it's a right angle triangle, triangle information, that angle is 90. This angle is 26. Therefore, I can be able to get O3. Sum of angles of a triangle. It's 180 degrees. So you can be able to get angle O3. What will be the size of angle O3? Sum of angles of a triangle is 180. Therefore, we'll say 180 minus 26 minus 90. We can be able to get O3. We can see our O3 is 64. Remember, we are still on analyzing that diagram and we're still on that first statement. Now our center theorem again. Which one do we see? Oh, these are radies. Remember your angle at the center theorem is twice angle at the circumference. You must let your fingers do the working. Always that if you want to see that diagram, you go to the center, you move on top of the radius, you go to the sides, and you must end up on the circumference of the circle. So you must let your fingers do the working. You start from the center, you walk on the radius, you go to the side. Angle at the center. Even remember this diagram, it's still angle at the center, twice angle at the circumference. What happens? You go to the center, you move on the radius, you walk on the chords, you end up at the... So this angle will be twice that one. The third diagram, you walk on the radius, you walk on the chords, therefore, angle at the center will be twice the angle at the circumference. So it's angle at the center twice. So you walk on the radius, you let your fingers do the king walk. So therefore this angle will be twice. O2 is twice angle K1. So which means this angle here will be 64 because it's angle O2 which is twice angle K1. So a statement and a reason. Remember our common errors that every statement that you put, you must give a reason. So it's angle at the center, twice the angle at the circumference. And we already have this angle. And these are adjacent angles on the straight line, which means we can be able to get that angle. Once we have this angle, we can be able to get. And remember, we're still on that. So you finish complete reading again. It says KOM bisect chord LN and MNO is equals to 26 degrees. So this was written on the diagram, so it made it life easy. So if the angles are not written on the diagram, the first thing that you must do, transfer these angles to the diagram. And it says K and P are points on the circle. Let's look at K and P. K and P are points on the circle with NKP equals to 32 degrees. So we've read and we've put flash and we've put our implied information. Now we can be able to get all these angles. Remember, we can get O1 because these are angles of the straight line. It's 180 when you add angle O1 plus O2 plus O3. It's 180. So we can be able to get O1. What will be the size of O1? Sum of angles on a straight line. So it's going to be 180 minus 64. Subtract 64. That we get angle O1 gives us 52. Once we have 52, remember OKP is an isosceles triangle. So we know that angle K1 plus K2 equals to angle P. So we can be able to get a K1 plus K2 and angle P. Again, triangle information. We use sum of angles of a triangle, 180 minus 52, which gives us 128. Therefore, we can be able to get the size of K1 plus K2 and angle P. So by merely analyzing the diagram, we can be able to get the whole information. Now, the questions were not there. I want us now to look at the question. Remember, we've analyzed the diagram. We were able to get the size of O3. We got 64. That is 90. And these we've marked off. And we know that it's an isosceles triangle. We could get the size of those angles. We got this angle as the angle twice K1. We got the size of this angle, and we can be able to get that. Now let's go to the questions. And you will see, before you could even look at the questions, we've answered the questions. It says, determine given reasons the size of O2. Oh, wow. The answer is there. O2. Answered. Then you write your formal answer. O1. Wow, the answer is answered. The question is answered. We were able to get O1. And prove given reasons Kn bisect. Remember, to bisect is to divide into two equal parts. Then you can get, because it says bisect, Kn bisect OKP. OKP is that angle. So if you get that this angle is equals to that. Remember, it's an isosceles triangle. We're able to get the sizes of these angles. Therefore, if you get this angle to be 32, therefore, we will have answered that it's bisected by Kn. So it's very important to analyze the diagram. And this is numerical question. And remember again, our WhatsApp interactive number 064 748 8913. Now, we've learned a skill of analyzing a diagram. Now, I want us to apply that skill. Now, if you look at this question, what I did, I've put in the questions there because in your question paper, the questions are going to be there. So, but you need to apply the skill that we've just discussed of analyzing the diagram. So this is another question on numerical. And what's going to happen, I'm going to give you 5 minutes just to analyze this diagram. And by analyzing, you'll be able to see that these questions will be answered. So your 5 minutes start now. Please analyze, and from there we'll talk to feedback. So your 5 minutes has started. Thank you. Back. Remember our WhatsApp interactive number 064 748 8913. We are back now again. I can see you smiling that you are now able to analyze the diagram. I can see your face shining, smiling because you're happy. Now let's go back. Again, remember that skill to say read the information at least twice. Read the information more than once. So I'm going to apply the same skill that I've shown you in the first diagram. O is the center of the circle. AB is the diameter. Angle AOC equals to 104 degrees. Angle DAB equals to 32 degrees. And the questions are given there. It says calculate the size of angle D, angle C3, angle A1, angle C2. That is just information. We read it so that, remember, it will sink in your mind to say which angles you'll be working towards. But remember, before you could even attempt those questions, we talked to analyzing the diagram. Now let's go back and read the information again. The information is the skeleton. We are putting flesh. Now, the first thing is to put those sizes of angles on the diagram because this time they are not there. We are given that angle AOC is 104 degrees. Let's go to the diagram and look for angle AOC. AOC, it's this angle. So this angle is 104 degrees. Let's put it there so that it makes our life easy. And angle DAB, it's 32. Let's look for angle DAB. Angle DAB. I'm moving slow so that you can be able to see that. DAB, which is DA2. So that angle there, it's 32 degrees. So once those angles are there, it will make life easy. Now let's go back again to the information. Now we've put that the sizes of the angles there. It says O is the center of the circle. O is the center of the circle. Remember your key word again? Center. Now you think of your center theorem. You think of the terminology that goes with center. Once we have a center, we can have radii, we can have a diameter, and we can have our center theorem. Now let's start with the terminology. Do we have any radii? So let's just change the color. Mark off the radius with a different color. So we have OA, which is a radius. So we mark it off with green. We have OC, which is a radius. So we mark it with green. It's a radius because O is our center. We have OB, which is a radius again. We mark it with green. And the same marking because these lines are equal. So AO, OC, OB, those are radii. Now again, look at triangle AOC. What's happened to triangle AOC? Implied information. Remember when we are analyzing helpful and useful information and the implied information. What's happening? It's an isosceles triangle. If it's an isosceles triangle, it means angle A1 will be equals to angle C1. Because triangle AOC, it's an isosceles triangle. Another isosceles triangle? Yes. Wow. OBC, it's another isosceles triangle. OB equals to OC. So when OB equals to OC, the same markings, remember. Therefore, C2 plus C3 equals to angle B. So we mark off those angles the same because those are isosceles. And remember, once this angle is 104 degrees, angle O1. So we can be able to get the size of angle A1. We can be able to get the angle of C1. Triangle information again. Sum of angles of a triangle is 180. So we say 180 minus 104. It gives us 76. And remember, A1 and C1 are equal. So we can divide 76 by 2. When we divide 76 by 2, we get this. A1 is 38. And C1 is 38. We are still on center. Now let's look at our center theorems. Do we have center theorems? Again, before, yes, AB is a diameter. Your center theorem. Angle subtended by the diameter or angle in the semicircle. Therefore, this whole angle here, it's 90 degrees because it is subtended by a diameter. Again, do we have any other center theorem? Remember, if we have radius, let your fingers do the working. We have the radius, we enter the circumference of the circle. We walk on top of chords. Angle at the center, O1, is twice angle D. Reason, please, angle at center is twice angle at the circumference. So you must write that reason. So if O1 is 104, twice D, you can be able to get the size of angle D. So you divide 104 by 2. Then you get that angle D, it's 52. So it was just center, and we're told again that AB is a diameter. We've already spoken about the diameter. Now again, any other useful information. Remember when I was talking about solving a rider, analyzing the diagram, you need to look at another useful information. Any other theorem that you see from the diagram. Any other theorem. Let's look at any other theorem that we see there. Let's look at this. Remember, D, A, C, B are on the circumference of the circle. And if we have 4 vertices on the circumference of a circle, we can talk to a cyclic quad. Now, we can be able to draw that cyclic quadrilateral. Now what happens? We've drawn our cyclic quad. So we have angles that are subtended by the same chord. We have angle D here, which is equals to angle B. So these two angles are equal. Remember, this is useful and helpful information. And again, we can see that angle A2, which is 32, is equals to angle C3. So we can write this to be 32. We said angle D is 52. We can write angle B to be 52 degrees. And we have O1 as 104. Therefore, O2 will be, because these angles on a straight line. So 180 minus 104, again, it gives you 76. So which means that will be 76. We can get our O2. Then when they start looking at the questions, by merely analyzing, you can see that we've answered all the questions. The first question says, calculate the size of angle D. Where's angle D? We got 52. By letting our fingers do the working, we can see that we walk on top of radius OC and OA. Angle at the center is twice angle at the circumference. We were able to get that angle that is 52 degrees risen. Angle at the center is equals to 2 times angle at circumference. Then C3, there is your C3. You will be able to calculate your angle C3. Remember, you have angles in the same segment. They're subtended by that arc. We got that A2, it's 32. Therefore, your C3 will be 32. Angle subtended by that arc DB. You go to your A1. That is your A1. We're able to get size of A1 by using the triangle information. C2, we can get C2 because we have the size of angle C1, we have the size of angle C3, we have the size of C1, C2, C3 to be 90. Therefore, we can be able to get C2. So by merely analyzing that diagram, we were able to answer those questions quick. So again, another one on numerical. Remember, when we come to the other questions, in terms of X, in terms of proving, we follow the same procedure that you analyze the diagram. So this time, I'm going to give you about 3 minutes for you to analyze the diagram, and you'll be able to see again following the same procedure. So the procedure that I've given you, the skill that I've given you of analyzing the diagram in every rider that you solve, whether similarity or proportionality, you will see that you're going to use the same skill. To say what you should do, you need to analyze the diagram before you look at the questions. So I'm going to give you 3 minutes. Then after that 3 minutes, we will talk to analyzing that diagram, because that is what is very important and critical and given the reasons. Your 3 minutes starts now. Remember our WhatsApp interactive number 064 748 8913. So let's interact. The number is 064 748 8913. And let me acknowledge one learner from Sutherland who was able to get all the answers from the previous question. Well done. So it shows that we are indeed interacting in this, and indeed we are analyzing the diagram. Again, this is a numerical question. The same skill that you've learned of analyzing. It's very important. If a question has got a diagram, analyze the diagram before you could even go to the question. Read it twice, but remember again that in an exam, time is part of the exam. O is the center of the circle, reading the information more than once. O is the center of the circle. STU is a tangent at T. Chord BC equals to chord CT. Angle ATC equals to 105 degrees. And CTU equals to 40 degrees. And the questions are given then. Remember, in your exam, the questions will be there. You can read them. There's nothing wrong in that. Calculating the size of A2, size of angle A1, the size of angle B1 plus B2, the size of angle C2. So those will be your questions. Now we read the information again. We match it to the diagram. O is the center of the circle. Now before, again, the sizes of the angles are not written on the diagram. So let's write the sizes of the angle on the diagram. So angle ATC, it's that angle T2. It's 105 degrees. So let's write 105 degrees there. Angle CTU, it's 40 degrees. We put 40 degrees there, so that we are aware about that, because these are numerical. Then we can go back. O is the center of the circle. Keyword, O is the center. Center, your terminology again. Your terminology comes back. And your theorems on center. Now let's change color and use a different color for our terminology. O is the center. Then we have OB as a ready. We have OC as a ready. Now again, once we've marked off that, we can see that this is an isosceles triangle. Triangle information again. What you've learned in grade 8, what you've learned in grade 9, what you've learned in grade 10, it's still important here. It's still very critical. So the angles that will be equal, B1 equals to C1. Good. Then let's go. Chord BC. Let's look for chord BC. Let's just change color so that we can mark it off with a different color. Chord BC. Where is chord BC? There is chord BC. Chord BC, it's equals to chord CT. So these two chords are equal. Then, therefore, what? That implied information. Remember, implied information. Therefore, once these chords are equal, it means these chords will subtend equal angles at the circumference of the circle. This is a corollary. Remember, I said you need to know your corollaries. So, chord BC equals to chord CT. Therefore, it simply means what? This angle will be equals to that, because chord BC subtend co-angle AC at the circumference. Chord CT subtend that angle at the circumference. Therefore, A1, A2 will be equal. That is the implied information that is very important. Because if you don't know that, you won't be able to answer some of these questions. And then, I've jumped that statement. Let's go back to it. It says, STU. Where is STU? There is STU. It's a tangent at T. Our keyword, tangent. think of your tangent theorems. Which tangent theorem will work here? Okay, I have a tangent. I have caught TC. So I have an angle that is formed between a tangent and a chord. So I can use my tan-chord theorem. And again, you let your fingers do the working. Where the tangent and the chord intersect, where the chord end, because there's the chord that I want to use. If you move on top of the chords, you'll end up at the circumference of the circle. You end up at angle A2. And we said this angle T3 is 40. So which means A2 is 40 degrees. Because angle CTU, which is T3, is 40. And we know that A2 equals to A1. Because we've already analyzed that. So we will know that this angle here, it's 40 degrees. And already we've spoken about angle at the center. That's our radius. We move on top of our radius. So angle at the center, O1, is twice A1. Write the reason. Angle at the center, remember the reasons. Angle at the center is equals to twice angle at the circumference. So if A1 is 40, substitute. Therefore, what will be the size of O1? It's 80 degrees. And once O1 is 80 degrees, we've already looked at the information of a triangle. So that is 80. Sum of angles of a triangle is 180. So already O1 is 80. So we can be able to get B1. We can be able to get C1. So what will be the size of angle B1 and C1? We're left with 100. We divide by 2 because they are equal. Therefore, that will be 50 degrees. That will be 50 degrees. Now, any other information that is useful and helpful, remember that. So the other information that is useful and helpful, it's the other theorems that are not mentioned there, but you can be able to see them on the diagram. Look at A, B, C, T. Those are points on the circumference of the circle. So therefore, what can you say about A, B, C, T? It's a cyclic quad. And you have got cyclic quad theorems. So if we have cyclic quad theorems, then we must be able to get that. So we know that angle T2 plus B1 plus B2 equals to 180 degrees. Why? That is a cyclic quad. Opposite angles of a cyclic quad are supplementary. And we know T2 is 105. So if it's 105, it's 180 minus 105, which gives us 75. It means that whole angle there is going to give us 75 degrees. So we can be able to get that angle there, which is 75 degrees. And you can be able to get B2, because once this is 50, it means B2 will give you 25 degrees. So that is 25 degrees. And remember again, triangle TAC, we have the size of T2, we have the size of A2, we can be able to get the size of C3. And once we have the size of C3, we have the size of C2, we can be able to get the size of C2. Now, by merely analyzing that diagram, you can see that you've answered all those questions. A2, we're able to get A2. A1, we could get A1. We could get B1 plus B2. We could get C2. And we were linking this. Remember, I said in Euclidean geometry, there's a lot of linking that we need to do and deduction. So these are numerical. So in terms of X, that's the next question. We follow the same procedure. Follow the same procedure. You analyze the diagram. Analyze the diagram. And this is in terms of X. Whether it's a proof question, follow the same procedure. Similarity, gonna follow the same procedure. So let me give you 2 minutes so that you can look at that one in terms of X. We're gonna follow the same procedure to say you read that information more than once. From there we analyze. 2 minutes, your 2 minutes start now. And remember your interactive WhatsApp number 064 748 8913. So your 2 minutes starts now. Our WhatsApp interactive number 064 748 8913. Now these are questions in terms of X. Remember, I said in Euclidean geometry grade 11, there are 3 types of questions: numerical, in terms of X, and proof. But the same skill that we've learned in analyzing the diagram, it's the same skill that we use. Don't be frustrated by the word in terms of X. So that should not frustrate you. Follow the same procedure. Read your information more than once. Again, in the diagram, O is the center of the circle, and E is the midpoint of chord AD. AO and EO are produced to cut the circle at C and B respectively. AD produced meets the tangent drawn to the circle at C in G. Angle O3 is equals to X. Now we've read that information once. Now we are going to read it for the second time, and we look at the diagram, we analyze. And before, remember, if we're given any variable or any value, first write that in your diagram. Let's check whether O3 equals to X. It's written on the diagram. Yes, it is. It is written. There is our O3 is equals to X. It's written on the diagram. So now let's go back. In the diagram, O is the center of the circle. We go to the center of the circle again. Remember the terminology. O is the center. OC is the radius. We mark it off. It's a radius. OA is another radius. Let's use 3 because already we've marked AE and ED has got 2 markings so that we show that this is different. And then do we have another radius? Yes, we do. OB is another radius. We mark it off the same again. So that is our radius, our radii. So we have OC, we have OB, we have OA. Again, now, triangle, yes, OBC, it's a triangle. So in that triangle, it means we have an isosceles triangle. Let's use a different color. Then we have B2 equals to C2. Because that is an isosceles triangle. Now, that is a radius again. Remember, OB and OA. In that, there's a triangle again. We have triangle OBA. So, it forms another isosceles triangle. So, let's change color and use a different color and mark it off. Then we have angle B1 equals to angle A1. So B1 and A1 are equal. So that is another isosceles triangle. And we are still on that center, remember, as our keyword. Do we have any center theorems? We have a diameter. Yes, that's a diameter. AC, it's a diameter. So angle B1 plus B2 angle subtended by the diameter, we mark it off. That angle, it's 90 degrees. So B1 plus B2 equals to 90 degrees. Information of a triangle, again, remember, if that is a triangle, you have an exterior angle of a triangle is equal to the sum of two interior angles. That is still another information that you need to know. Now, it says, again, E is the midpoint of chord AD. So, E is the midpoint of chord AD. So, that is AD. So, if the midpoint again, this line is drawn from the center. Line drawn from the center to the midpoint of the chord is perpendicular. So, which means this angle here, it's 90 degrees. And that angle there, it's 90 degrees. So, E1, E2, it's 90 degrees. So, we've marked it off. Let's continue reading. And says, AO and EO are produced. So AO, there is OO, it's produced. So it's produced, it means it's a straight line. EO, produced, EO is produced, it means that is a straight line. And then it says again, to cut the circle at C and B respectively. So it cuts the circle at C and at B. AD produce meets the tangent drawn to the circle at C. Now let's look at AD. AD is produced. It meets the tangent, which is a tangent at C at G. So it means CG is our tangent. Our keyword again, it's a tangent. Now let's look at the tangent again. There you remember that midpoint helped us. Tangent, we think of our tangent theorem. Now, think of all your tangent theorems. That is a radius, that is a tangent. How? Radius perpendicular to the tangent. So it means that angle, it's 90 degrees. So C3, it's 90 degrees. And again, do we have tan chord? Yes, that BC is a chord. And that is a tangent. Remember where the tangent and the chord intersect? Where the chord intersect, end at the circumference of the circle, you let your fingers do the working, which means C1 will be equals to A1. And again, remember, AC, it's a chord. It's a special chord, even if it's a diameter, but it's a chord. So where my tangent and the chord intersect, at the end of that special chord, which is a diameter 90, and it's true, this is C3, it's 90, and that B1 plus B2, it's 90 degrees. So you can be able to see that. Now, any other information that is helpful, any other. AC, BE are intersecting lines. Remember your earlier theorems that you've learned. Once they are intersecting lines, these are vertically opposite angles. If O3 is x. It means I can say O1 is x. And then another information, once O1 is x, this is an exterior angle of triangle OAB. So which means A1 will be half x. That is half x. Because the exterior angle of a triangle is equal to the sum of two interior opposite angles. Or again, its angle at the center is twice. So we are able to get that angle as x. And then we've analyzed that diagram. We've analyzed it. Now you look at the questions and you will see whether it's in terms of x. You've already answered the question. And the first question says, why is EOCG a cyclic quad? Let's go to EOCG. EOCG there. How is the question asks, why is it a cyclic quad? It's a cyclic quad. Why? Remember, when you're proving a cyclic quad, you can either prove that exterior angle of a quadrilateral is equal to the interior opposite angle, or you can prove that opposite angles of a quadrilateral are supplementary, or you can prove that angles in the same segment are equal. Now this time we have opposite angles, E2 and C3. When you add them, they give you 180 degrees. So these are opposite angles. So because they are opposite angles and they give you 180 degrees, that is why EOCG is a cyclic quad. So the reason, so when they say why, they want you to give a reason. And what will be the reason? The reason will be opposite angles of a quadrilateral. I don't mention cyclic quad because I'm proving that this is a quadrilateral. Opposite angles. If you want to mention cyclic, you say converse of opposite angles. You mentioned the word converse before. So then you will be able to say that is a cyclic quadrilateral. Opposite angles of a quadrilateral are supplementary. Or you can say converse of opposite angles of a cyclic quad. And the next question says, write down and remember one other thing that is very important and critical in Euclidean geometry. Once you've proven something above, you can be able to use it. Once we've proven that EOCG is a cyclic quad, we can be able to use it. We can be able to see an exterior angle of a cyclic quad is equal to an interior opposite angle. Therefore, this angle will be x. Because we've proven that EOCG is a cyclic quad. So we can use that information because it holds. The next question says, write down with reasons two other angles equals to x. Already we've written that O1 is x. Intersecting lines, vertically opposite angles. And again we have G as x. We use an exterior angle of a cyclic quad is equal to the interior opposite angle. So already, the size of A1, already we said A1 is half x, because we've analyzed our diagram. And then C1, remember from our turn chord, by analyzing that diagram, we could be able to get C1, turn chord. Your C2, we have this angle, it's 90. We have this as half x, we can be able to get C2. So it doesn't matter whether it's in terms of x, whether it's proof, whether it's numerical, you use the same procedure. Let's go to the next question. Now it's a proof type question. It's high order question. We use the same skill that we've used of analyzing the diagram. So this time, I'm going to analyze this diagram with you so that we can see whether do we use the same skill. In the diagram, a circle passes through D, B, and E. Diameter ED of the circle is produced to C, and AC is a tangent to the circle at B. M is a point on DE such that AM is perpendicular to DE, AM and chord BE intersect at F. Now we've read that information once. Let's read it for the second time. And we are now putting that information on the diagram. And we use our keywords. In the diagram, a circle passes through D, B, and E. Let's look at D, B, and E. There is D, there is B, there is E. Those points are on the circumference of the circle. Diameter ED of the circle is produced. So there is a diameter. So once we talk of a diameter, remember it means there would be a center somewhere, but we were not told where the center is. Now when we look at that diameter which is produced, what do we have? We have the triangle DBE. So this angle B2 will be 90 because it is subtended by the diameter. So that angle there, it's 90 degrees. And our keyword there, it's a diameter. So the diameter, remember, talks to our center theorem. And it's produced to C. It's produced to C. And AC, it's a tangent. How? AC, it's a tangent. Our keyword, tangent. Now, we look for our tangent theorems. We have a chord, we have a tangent, we have angle B1. Where the tangent and the chord intersect, where the chord ends, let the fingers do the working. So which means B1 equals to angle E. We let our fingers do the working. So again, we have another tangent and a chord. Yes, that's a tangent, that's a chord. So it's B3. So B3 will be equals to D2. So B3 and D2 are equal. And this angle M2 is 90. Therefore, my M1 will be 90. And then M is a point on DE. M is a point on DE. That is that point. Such that AM is perpendicular to DE. Perpendicular, again, we've already marked off. If it's perpendicular, M2 is 90. Therefore, M1 will be 90 degrees. And AM, where is AM? AM and chord BE intersect at F. They intersect at F. And again, once we have intersecting lines, we will have vertically opposite angles. We can see that F1 will be equals to F3 because these are vertically opposite angles. And we have F2 will be equals to F4, vertically opposite angles, because we have vertically opposite angles. Now, so we've analyzed the diagram. And from this diagram, actually, you could be able, again, to deduce your own questions. But let's look at the questions, whether they are not answered. The first question says, prove given reasons that FBDM is a cyclic quad. Remember, we've analyzed the diagram. It says prove that it's a cyclic quad. FBDM. We must prove that FBDM is a cyclic quad. Let's take a different color. So we must prove that this is a cyclic quad. Wow. By analyzing M1, 90. B2, 90. Opposite angles, 180 degrees. Therefore, it's a cyclic quad. So now you do your write up. To say B2 is 90, you will start by writing B2, 90 degrees, angle subtended by a diameter. M1, 90 degrees. Why? Because AM is perpendicular to DE. And then M1, B2 plus M1 gives you 180 degrees. You say, therefore, FBDM is a cyclic quad. Your reason will be opposite angles of a quadrilateral are supplementary, or you say converse. Can you see you've answered that question? by merely analyzing. And if we look at the next question, it says prove that B3 equals to F1. B3 equals to F1. Where is your B3? There is your B3. It says you must prove that is equals to F1. And remember, once you have proven that it's a cyclic quad, you can use that information. So if you've proven that B3 equals to F1, you must be able to link all that information, remember? And remember, B3 and D2 are equal. And again, remember, we have F1 and F3 equal. And that is, we have already proven that that is a cyclic quad. So your linking part comes in. You must be able to link F1 equals to D2. And then again, it is equals to B3. Therefore, those angles, tan chord, B3 equals to D2, F1. So you link, we use that same information. And then this, we look at it when we talk to similarity. So the same procedure, whether it's in terms of X, whether it's numerical, whether it's proof type questions, which are high order questions, you still use the same skill, the same procedure. So that was basically grade 11 theorems. Now let's go to proportionality. Now on proportionality, remember we said, again, this is still Euclidean geometry. Even Euclidean geometry, you still need to analyze the diagram. Same skill, same information. Now let's look at this one. Remember, in terms of proportionality, you work in one triangle at a time. And I usually say it's a 5-point theorem. Why 5-point theorem? You will have your vertex, and you look at the parallel lines. I have parallel lines here, where the parallel lines end. Parallel lines indicated in red. So it's a 5-point theorem, vertex, my parallel lines, and my parallel lines. Because parallel lines are very important. Remember, the theorem says a line drawn parallel to one side of a triangle divide the other two sides in the same proportion. And remember, these theorems you could be asked to complete. And that is a knowledge question. It's level 1. And remember again to analyze the diagram. When you analyze the diagram, you read more than once. Again, let's read. And we look at our keywords. And we look for the information that is critical and that is useful. They say FE is parallel to DC. Where is FE? You can see again it's marked with the same color. As I said, color is very important. Same color. Just highlight it so that you can see it. Red, our 5-point theorem, it's red. So 5-point and parallel. So these are parallel, and we are given that again DE is parallel to BC. Let's use a different color. DE, there is my DE, parallel to BC. Parallel. So we have two pairs of parallel lines. But remember, you must work in one triangle at a time when you want to write the correct proportions. So the first one is in triangle ADC. So it's in red. So our 5-point theorem again, it's in red. So we can be able to write our proportions because we have that. We have a line, we are given that lines are parallel. So we can have a proportion AF over FD. So, and remember, in terms of proportionality, it must be the same movement. If I write AF over FD, it should be AE over AEC. If I write AD over AF, it should be AC over AE. The movement should be the same. Now, Here the question says, and again, another triangle. We have triangle ABC. Our 5-point theorem again will work. Again, my 5-point theorem. The lines that are parallel are those. So I'm working in triangle ABC. So you're able to see your different triangles. And we are given that AF is 4 centimeters. It's 4. It's written. It's a length. DF is 6. It's 6. AE it's 8. It's 8. So those lengths are written there. So they are written. So it makes life easy. The first question says, determine. We've written that, and we can be able to write our proportions. I can have AF over FD equals to AE over EC. Now the first question says, the length of EC. Wow, can I be able to get it? Yes, because my 5-point theorem, in which triangle? And you can see EC, it's in triangle ADC. So I will say in triangle ADC, which proportion can I use? Better to start with, then I have AF over FD equals to AE over EC. Reason, prop theorem. And once you say prop theorem, write the lines that are parallel. FE is parallel to DC, or you can write the theorem line drawn parallel. Then you substitute 4 over 6 equals to 8 over EC. Then you can be able to get the length of EC. Because EC is in the triangle ADC. The next question says AB. Here is very important again to identify the triangle that you're working in. The length of AB. Where is AB? AB is that length. So AB, it means it's in the big triangle. So I'll work in triangle ABC. So where will my 5-point theorem work? In that. So DE parallel to BC. So the same movement will work. So what is our length for EC? Remember, it's 8 times 4, which gives us 32. We divide 32 by 4. 8. So, which means that length is, no, it's 8 times 6, I'm sorry. Divide by 4, which gives us 12. So, which means the length of EC is 12. So when we're looking for AB, it's that whole length. So we need to use the ratios again. Remember to write the correct ratio. So because it's AB, so we can use the ratio of AB over AD over AD. So same movement. So it must be AC over AE. It should be the same movement. AC over AE. Remember to write the reason. Correct reason. Line drawn parallel to one side, or prop theorem, and you write the correct parallel lines. DE parallel to BC. And then you can substitute your AB, that's what you're looking for, over AD. 4 plus 6 is 10. You substitute your 10. AC, 8 plus 12, it's 20. You substitute your AC, it's 20. And then AED, it's E. Then you'll be able to get the length of AB. The next question, it's in terms of areas. Remember, we said in terms of areas, and this is written in column form. And you can be able to write it in fractional form. Therefore, if you write it in fractional form, you have area of triangle AFE over the area of triangle ABC. So it's written in fractional form. So it will make your life very easy if you write it in fractional form. So it's the same as this. Now they say determine area of triangle AFE is to area of triangle ABC. Now let's look for triangle AFE. Let's change color. Triangle AFE. Where is triangle AFE? There is triangle FAFE. I'll just shade it. This is triangle AFE. And triangle ABC. ABC is the whole triangle, the big triangle. Now we look at it. What is it that is common there? Oh, what is common is angle A. Then I can use the area rule because angle A is now the common angle. So what is our area rule? Remember the integration of topics here. Area rule, you use it in trigonometry, but we are integrating topics. You don't work maths as silos. Maths shouldn't work as another topic becomes an island. So I can use my area rule. Just want to erase. So I'll use my area rule. Remember, we are looking in this triangle and the big triangle. So it's area of triangle FAFE over the area of triangle ABC. So our area rule will be half, and our common angle is A. So it's half AF times AE sine A over the big triangle, half AB times AC sine A. Then what happens? Half and a half sine A, sine A. What is the length of AF? You substitute, it's 4. AE, it's 8. AB, that AB length that we got from the previous question, you substitute it. AC, remember AC, it was 8 plus 12, it was 20, you substitute. Then you get your answer. Then you'll be able to get this area problem. So check what is common, and color will assist you because you'll be able to shade. Now the same on proportion here. That time you are given lengths. Now this time you are given ratios. Remember the same procedure to read the information twice. So remember again, use it, read the information twice. W is the midpoint of PR. ST is parallel to QW. W is parallel to RS. And PQ over SQ is equals to 7 over 2. QW and SR intersected V. Now we read this information, we relate it to there. Now this time we are given ratios. These are not lengths. Now let's go. W is the midpoint. W is the midpoint. Ghana midpoint means what? Divide into 2 equal parts. So which means if it's the midpoint, it means PW equals to WR. So they're the same. And ST is parallel to QW, our 5-point theorem. Let's look at ST. Oh, there is my ST. It's parallel to QW. Oh, there is my QW. So in which triangle is this 5-point theorem? It's this triangle. Oh, that is triangle PQW. I'm able to identify the triangle. And I'm given again WA parallel to RS. Let's change color. WA parallel to RS. My 5-point theorem again, I can put it on that side so that you don't get confused. and it makes life easy for you to be able to identify the triangle. So it means I'm working in triangle PSV, parallel. Oh, the ratio. So two triangles. Remember, in terms of proportionality, you must work in one triangle at a time. So I'll work in triangle PSR. I can identify my triangle. PQW, I can identify my triangle by using my 5-point theorem. And again, what is it that is given to me? PQ over SQ is equals to 7 over 2. Let's go to PQ. PQ, it's 7. It's not a length, we introduce our variable. So it's 7K. And SQ, where is SQ? SQ, 2K. We introduce a variable because it's not a length. You cannot just write 7. So you can look at the proportion. In which triangle is this? My 5-point theorem again. PQW. Okay, if this from there to there, it's 2K, it means I can write that to be my 5K. Because 2K plus 5K gives me the 7K. This is that implied information. The information that can be able to assist you. Then I can be able to write the other ratios on that side. If that is 5K, that can be 5X. 2K, this is 2X. And remember we said that is the midpoint. Which means what is PW? PW, it's 7X. Which means what is WR? It's 7X. Why? Because W is my midpoint. And if it's my midpoint, it means PW and WR are the same. And from there, you can be able to answer the questions. It says PT over TW. PT over TW, already I've written those ratios. PT, TW, 5 over 2. By analyzing the diagram. PT over TR. PT over TR. My PT is 5X. My TR, 7X plus 2X, it's 9R. You can be able to write. But remember always to write the reasons. Very important. PA over SQ. Your PA over your SQ. You have your PA as 5K. Your SQ as 2K. You can be able to write. QV over VW. Now you must be able to identify your triangle. QV VW. QV over VW. Look at QV over VW. It ends there. It's a vertex. It's a point there. It's a point there. My 5-point theorem. Oh, I've put a point there. Parallel to that. Oh, I've put a point there. Parallel to that. So my 5-point theorem still works here. Because that is parallel to this ones. So I can be able to get my QV over VW. I have SQ over AQ. So my 5-point theorem still works because I can be able to identify the triangle and be able to work in that triangle. In terms of similarity, remember you can either prove, you can be given that triangles are similar. Triangle ABC, similar to that. Remember I said you have direct application and indirect application. If you are given to prove that triangles are similar, this is direct application. It's direct because you simply prove triangles to be similar directly. So there are two ways. The two ways, it's either you use by proportion or you use by equiangular. This is just an example in terms of proportionality. Remember, two ways here. It's direct application as it was stated earlier on to say you need to prove that triangle ABC is similar to triangle DEF. Now you are given lengths. So we use the first way of proportionality. Now, remember, when you are given that to prove that triangles are similar, you are always given those triangles in order. They are always given in order. So the way they are given in order. So, and when you using similarity, order is very important. Remember that interrelated concept. Similarity, equiangular, and proportionality. So they're interrelated. So order is very important so that you can be able to write your proportions. And always when you are given to prove that triangles are similar, please write the proportions. Even if the question did not ask you to write the proportions, write them. How do you write your proportions? Before I prove your proportions, you write your eyebrows, which is AB, over your eyebrows, which is DE, equals to your eyebrows, which is BC, over your other eyebrows, which is EF, equals to your smile, which is AC, over DF, your smile, DF. That's how you write your proportions. So it's your eyebrows, and then smile. Why? Because this will assist you. Because normally the questions that follows in similarity, they will want you to use that. So in this term, your AB over AC, where's your AB? Your AB, it's 15. And what is your AC, your DE? Your DE, it's 45. And when you simplify this, you can see you get 1 over 3. And what is BC? Your BC, it's 10. And EF, it's 30. It gives you 1 over 3. And what is AC? It's 8. DF, it's 24. It gives you 1 over 3. So we can see that these sides are proportion. Then you can conclude and say these two triangles are similar. Triangle ABC is similar to triangle DEF. And you mention the reason. Sides of proportional triangles. So you give a reason. So it's very important that you give a reason. Because remember, every statement that you put, you give a reason. So then we can be able to say that are similar. It's because this is given in order. And when you prove using proportionality, you must do all the sides. It's not the same as when you are using angles. Remember, when you are using angles, you're able to get 2 angles. The third angle, you can conclude. But when it's in sides, you must do all the sides and check whether the ratios for those sides are the same. So you follow the same procedure here. When this information was not written on the diagram, make sure that you write it on the diagram. So write it on the diagram. So you'll follow the same procedure. So let me quickly move on this one, which needs equiangular, which is direct application of similarity. You can see here you are not given lengths. So when you are not given lengths, you use angles. So it's the direct application. The previous one that we've done, we were given lengths. As such, what did we use? We used the lengths to prove for proportionality. Now this time, we are given this information. Remember, this is grade 11 theorem, but we are using it in similarity, and similarity, we learned it in grade 12. So you can see that you don't work content in silos. You use it together. Same information, where you read the information and look for your keywords, analyze the diagram. So the analysis of a diagram in Euclidean geometry is very important. It's very critical. It doesn't matter whether it's grade 11. content, it doesn't matter whether it's proportionality, it doesn't matter whether it's similarity. Because once you are given this diagram, remember they say it's a quadrilateral, it's a cyclic quad. So those are your keywords. Intersecting at E, intersecting lines. You have your vertically opposite angles. Again, remember your Euclidean geometry, your analyzing of a diagram. So you can see that is very critical. That is very important. By taking this information, analyzing it, you're able to see. And the question says, prove that ABE is similar to DCE. Now, ABE, look at triangle ABE. ABE, it's that triangle. So ABE, E, better write E1. If you have triangle ABE, just write E1 there so that you're able to see that that angle is E1. DEC, triangle DCE. Which angle is that? Just write E2 so that it assists you, so that you see. Remember when I was talking about common errors, I did talk about labeling the angles incorrectly. So once you've labeled it like that, you know that the angle is E2. And remember I said this is always put in order. So it means angle A will be equals to angle D. So and indeed, so it's in order. So you can write it. So the alphabets are in order. Angle B will be able to angle C. And B is C. Angle E1 is E2. E1 is E2. So if you are applying it directly, the angles are mentioned in order. And as I've mentioned, order is very important in similarity and in proportions so that you can be able to write the correct proportions. Remember, even if they did not ask you to write the proportions, write them. There's no one who's going to make you wrong because you've given the additional information. Write the proportions of this because normally in the following questions, they will want you to use that proportions. Write them to say AB over DC. Remember your eyebrows equals to eyebrows, BE over CE, eyebrows, and your smile, AE over DE, your smile. So write these proportions once you've proven similarity. Because this information, you will want to use it in the following question. So it's very important that you write those proportions. So this is the direct application of similarity. Very important. The interrelationship of the content that is there. Again, this question talks to the direct application because the first question says here, you must prove that these triangles are similar. So it's the direct application. They're given in order. And there is indirect application. The indirect application is when you are given the proportions. When you are given the proportions, this is indirect application. Because you yourself, you must be able to identify the triangles that are similar. So this is indirect application because from the proportions that are given to you, you must be able to identify triangles because if you are given triangles in this form, you are not given triangles to prove. So we say this is indirect proportion application because you must first identify triangles. It's different from that one. Now, the indirect application, remember, I said is type A to type E. Type A to type E. And in type B to D, they're written in product form. Thus, it's a different form. So type B to D, you can be able to change all this to fractional form. And That's an advice that I give to say change to fractional form. It makes life easy for you to be able to identify the triangle and apply. And when it's type E, once you see type E, that has got a bracket and a square, a plus or a minus, it indicates that you need to use your Pythagoras theorem. It gives you a guidance. Once you see this, use your Pythagoras theorem. So it means, first of all, you need to prove your similarity and you need to use a Pythagoras. Once you see there's a plus or a minus, Pythagoras theorem. Now, questions that have got proportionality, you first need to identify a triangle. So identifying your triangle, you need to go horizontal or vertical. When you go horizontal, you look at your proportions, you go horizontal. That's what I mean. Now, when you go horizontal, you are able to identify a triangle. Now, on this example, there's no diagram. This is just information, a skill that you can use. A and BD, you can see A and BD is not a triangle. This does not form a triangle. So let me go vertical. Where I go vertical, you go vertical. AME, how M repeats, it means it can form a triangle. BDF, it forms a triangle. So therefore it means I can be able to identify a triangle from there. So this is a skill that you can use to identify triangle if you are given ratios. Let's just apply what you've learned there. Again, same. It doesn't matter whether it's similarity of what. The information, again, read it twice. Look for the implied information. Your keywords, work again. Now here, it's indirect application because they did not tell you to prove for similarity. But for you to be able to prove this ratio, you need to prove similarity. Now, again, remember, you need to read and look at the keywords. You are given diameter, you are given chord, a circle ADCB, use you must still analyze the diagram because this is still Euclidean geometry. It doesn't matter whether it's similarity. It's still Euclidean geometry, and this is grade 11. And EP is perpendicular to AB, so you analyze. It's a diameter, angle D, it's 90 degrees. And they talked of circle ADBC, ADBC. It means these 4 points lie on the circumference of the circle. And if lie on the circumference of the circle, it means that is a cyclic quad. And again, if you look at in that triangle, this is subtended by that which is a diameter, which is 90. Sorry for that, 90 degrees. And because these angles you can see, they will be equal because that 4 points are at cyclic quad. So this is 90, 90. And we are given again that P1 is 90, which means this will be 90. And because that's a cyclic quad, which means A2 is equals to B2. I was just analyzing. Now I need to identify a triangle. Go vertical or horizontal. Let's start by going horizontal. BPD, it's horizontal. It's 3 alphabets. BP, because B repeats, BPD, BPD. But you can see BPD does not form a triangle. So which means horizontal does not work. I go vertical. BPE, BPE, BPE. Oh, it forms a triangle. So it means that's the first triangle that I identify. The next one, because I've gone vertical on this ratio, even on that ratio you must go vertical. BDA, D repeats, BDA. So it means which triangle I must identify. Let's just change color. It's the big triangle. Wow. I've identified my triangles. Now for me to be able to prove this ratio, this proportion, I need to prove that these triangles are similar. So which means my triangle are BPE and BDE. You can write the triangles BPE and triangle BDE. And remember, I said order is important. This time I did not write them in order. I wrote triangle BPE, and triangle BDA. You must be careful. You must write them in order. But they could be in order because I started at B and I went to a 90 degrees. It's a 90 degrees, I went to that. And again, remember I said to assist you, just write the subscript. BPE, it means it's B1. So it's B1. Angle P, it's P2. So it means here it's P2. E here, the angle that I'm working, it's E3. So it makes your life easy. You're able to identify those angles even when you write them. So the next one, BDA, the big one, it's still B1. D, it's D. A, it's A1 plus A2. So you can be able to prove similarity from those triangles. Let me give you 2 minutes so that you can, a minute so that you can look at that diagram in a while and you look at it and you see whether you understand that. Thank you. Now, remember the question here, we are proving BP over PE equals to BD over AD. So it's an indirect application. That is why we first had to identify the triangles. So we've identified our triangles as triangle BPE and triangle BAD. So it's triangle BPE and triangle BDA. So we've written that is B1. So we can see B1 is in triangle BPE. I write angle B1 is equals to which angle? B1 again. It's common because that angle is common in both the triangles. So it's a common angle. So it's our B1 and our B1. The next angle, P2, I still write it under triangle BPE. So the angles that fall under triangle, if you're not sure, that will help you in writing this in order. If you're not sure whether you've written these triangles in order, the way that I'm doing it will assist you. It will always be correct. You write the angles of this triangle of BPE under BPE. The triangles of BDA
under BDA. Then when you label your triangle, you can just say BPA according to those angles that you've given there. So here P2, remember P2 is 90, and angle D is 90. Remember angle D, we got it from above. That's the statement that you needed to write above when you were analyzing, to say angle D is equals to 90, because it was not given. It's an implied information. So we'll write angle D is 90 degrees, angle subtended by the diameter. P2 it's 90, it's given, it's from there. So you say both are equals to 90 degrees. Remember, when you're using angles, once you have two angles, you have two reasons. The third one, you just conclude. So it's angle E3. E3 equals to A1 plus A2. So E3 equals to A1 plus E2. So these are third angle. You can just say third angle of a triangle. Then from there, you conclude and say, therefore, let's write it here. Therefore, triangle BPE is similar to triangle BDA. Reason, remember, angle. Then from there I can write my ratios. BP, which is eyebrows, over eyebrows, which is BD. Eyebrows, PE. By eyebrows, our triangle is DA. Smile, BE. BA. Now you need to identify the ratio. Remember, it's BP, there is my BP. I have PE, I have PE. BD, DA, so which means this ratio doesn't work. Therefore, I can write it in that ratio. Remember, when I was showing you that you can write it in fractional form, in colon form, in product form, to say you can change that BP over PE. So it's BP over PE equals to BD over 80. So you've proven. So this is indirect application of your similarity. Let's look at the next question. And in this next question, I want us to look at type E, because type BCD follows the same procedure. Identify the triangle, write it in terms of type A in fractional form. Then from there, you prove your similarity. So I want us to look at type E, where I said when you have a bracket and a square, plus or minus, then it simply means you need to use your Pythagoras. So your Pythagoras is very important here. Remember, again, we follow the same procedure. It's Euclidean geometry. We analyze the diagram before we could look at the questions, and it makes life very easy. So this example here talks to the one where there is a plus and a minus. So again, remember to say we still need to analyze the diagram. So I'm just going to give you 2 minutes so that you look at that diagram and be able to analyze and see how far we can go. And from there, we'll do the feedback. 2 minutes starts now. Thank you very much. Remember our interactive WhatsApp number still working 064 748 8913. So this is the last type of indirect application of similarity. So it's the combination actually, and you can see that normally these are high order questions. It's level 3 and a level 4 question. But again, remember, don't lose focus. The same skill that you learned to say you need to analyze the diagram. Analysis of the diagram is very key in every question that you answer in Euclidean geometry. Read the information more than twice. Again, let's read in the diagram alongside. LK is a diameter of circle K, LKN with center P. R and S is a tangent to the circle at N. T is a point on NK, and TP is perpendicular to KL. I just read that information. Now we're going to analyze the diagram looking at the keywords. In the diagram alongside, LK is a diameter. So where is LK? LK is a diameter. If LK is a diameter, you think of your center theorems. Do we have any center here? They did not say the center is P with center P. So P is our center. Let's just take a different color. P is the center. I'll make it green. So P is the center here. So which means LP and PK are the radius and LK is a diameter. Now center theorems? Yes. Which one? Oh, the angle subtended by the diameter, it's 90. So this angle is 90 degrees. That angle is 90. So, and they said that this angle that is given there, it's 90. So this, it's a straight line that is 90. Angle on the straight line is 180 degrees. And they say R and S is a tangent. Now let's think of our tangent theorems. So a tangent and a chord. So now we are looking at chord NK. Where the tangent and the chord intersect, let your fingers do the walking, the walk, they read at X. So which means this angle here will be X. Because we are given that angle L is X. So which means that angle is X. And then again we have our tangent. That's the tangent. And the chord, that's the chord. And that is the tangent. So if that is the chord, the tangent at the point of contact equals, so N1 will be equals to, let's mark them off the same, will be equals to K. Even if LK is a diameter, but it's a special chord. Then you can be able to prove, because we've analyzed the diagram, we have all that information. They say we must prove that KTP. So KTP, it's that triangle. Remember K, it's K. P, it's KPT. We have K. T is T2. You can just write your T2. That helps you to see the angle. And then KPT, we have this angle here, it's KPT. And then we must prove that it's similar to KLN. KLN. So it's the big triangle. The big triangle. So let us erase so that it becomes a bit clear. So we are looking in this triangle. And the big one. That's where we prove similarity. Remember, we've already analyzed. And this is already put in order. So which means your K will be equals to that K. So you say angle K equals to angle K. That's your common angle. It's your common angle. And again, what do we have? We have angle This angle here, KPT. KPT is equals to angle N. It's that, this and that one. They are equal, angle N. 2. Remember N2. It's 90 degrees, angle subtended by the diameter. So you'll have a reason that both 90. The third angle, you concluded it's T and L. So it's angle T equals to angle L. So it's your T2 and your L. So that's your third angle. And from there you conclude and say, therefore triangle KTP is similar to triangle KLN, and you write the result. Angle. Remember, they did not ask you to write proportionality, but I said when you talk to similarity, always write your proportions. Write that proportion KT. Write the proportion KT over KL, your eyebrows, equals to TP over your LN, eyebrows equals to KP over KN. Write those proportions because those proportions will be able to assist you. So now you look at the second question. It says KT and KN. So KT is there and your KN is there. So which means this proportion won't work. So the proportion that you're going to use is KT over KL is equals to KP over KN. And you can cross multiply because this is a product. And remember, it has got a minus. Once it has got a minus, it means now you must use your Pythagoras. Pythagoras is very important because there's a minus. That is that type E, which needs you to use your Pythagoras. So you can cross multiply. You have your KT times your KN. So that is your KT times your KN. And you multiply KL times your KP. Now you look at your diagram. Where is KL and where is KP? There is KP and there is KL, the entire. So these two lines relate. There's a relationship. So in terms of relationships, it's very important to say you need to look at the relationship. Because if you look at KL, KL is twice KP. So I can replace KL by KP. So you have 2KP. And when you multiply it by KP, you have 2KP squared. So it gives you a 2KP squared. And where is KP? KP is in this triangle. And that is a right-angled triangle. And you can use your Pythagoras. Because you have KT. There is KT. KT is your hypotenuse. And then you use your Pythagoras theorem. KT squared is equals to PT squared plus KP squared. And you write it in terms of KP. What will you have? KT squared minus PT squared equals to KP squared. Then you replace this KP by KT squared minus P. And that's the replacement. So once you see a minus or a plus, that type E, it wants you to use your Pythagoras theorem. So your Pythagoras is very important in your type E questions. So your type E questions will want you to use your Pythagoras theorem. So thank you very much. Thus, Euclidean geometry, remember, analysis of a diagram is key. Analysis of a diagram before you could look at the question is very important. So thank you very much. This was a good lesson. Hopefully the skill that was imparted, it's a skill that you'll be able to use when you use your Euclidean geometry, which is 40 marks in the question paper, And whether the question is numerical, whether the question is in terms of X, whether it's proportionality, whether it's similarity, it's very important that you analyze your diagram before you go to the questions. Thank you very much for watching the lesson. Remember, COVID is still here. It's still around us. You still need to sanitize. You wear your mask and maintain social distancing and keep safe. And all the best. Love you very much. Keep well. Thank you.